Okay, guys, we're making our way. We're done with 3 families. Now let's work on the 4th one. This is a rational function. That's the name of the family. The parent function is our 1 over x, so y equals 1 over x. And so this is our first asymptote at x equals 0, because you cannot plug 0 in the denominator of a fraction, and so we would say undefined right here at the 0. So remember again, when you're graphing this, you're going to have an asymptote. The graph will not touch that line. And then I'll just start plugging in values. If I plug in to the right of x equals 0, 1 divided by 1 is 1. And as my x's increase, my denominator gets larger and larger. And so I'll have this first point, 1, 1. A lot of them have that one, yeah? And then as I move to the right, however, I'll start getting closer and closer to the x-axis, but I won't exactly touch the x-axis. And our table doesn't include any fractions to plug in, values of x that are less than 1 but greater than 0. But hopefully you remember that when I do that, I actually start getting outputs that are integers that are greater than 1. And then when we were doing our hand gestures, I saw that a lot of you guys remember that there is, again, 180-degree rotation for the points that you see. These would be the points that would start to give you fractions. So if I plug in the -1, I'll get a -1. And then when I plug in -2, that's when I'll get all those fractions, but they're negatives. Similarly, if I plug in -1/2, I'll get 2, -1/3, I'll get 3, -3, and so that's your parent. And writing our graphing form, let's stay consistent with the other examples. Let's stick a 2 outside of the original function, which would be 1 over x. But wherever my x is, that's where the parentheses would go, so x minus h. And it's shifting the asymptote. And then plus k. And that would be a vertical shift. And so, oops, I put a 2 right there. I should have put an A right there. So just, I can't find my eraser right now, just stick an A right there, sorry. Let's go ahead and do an example of a transformation of this. Let's do a stretch of 2, a shift, a horizontal shift of 1, and then a vertical shift of 2. So my locator point, much like our other 3 examples, I've just chosen the same one. It's not like it's always like that, just wanted to be consistent, over 1 up 2. And instead of having that point immediately over 1 and up 1, and I'm sorry that I did that, that would be our asymptote, so that's not going to be a point. But you can kind of think of it as a point, because from that point is where you would have these 2 values, right? What I would have had is my -1, -1, and my 1, 1. But instead of it being immediately like diagonal, it would be over 1 and up 2, and backwards 1 and down 2. And so you still kind of get this general shape like that, but they're further away from that like locator point right there. Okay, this is our first graph that we did have an asymptote. Again, let's talk about the attributes of the parent. And the shape was that it's a curve. It does have some symmetry. It more so is a rotation about the origin, 180 degrees. The domain has all reals, but I cannot plug in the vertical asymptote. The range would also be all reals, but like a fraction is going to keep getting a larger denominator, it's never ever going to equal 0. And so on my parent graph, I could actually do a dotted line from that locator point, and it's never actually going to touch that line right there. My max and my min, I don't really have one. My max and min are both going to be -infinity and infinity. So my min is -infinity, and then my max is +infinity. And so you just kind of get a general shape of my hyperbola. And that is our parent number 4.